you have two possibilities for what a reaction is going to do as far as heat is concerned. You can either have an exothermic process, or you can have an endothermic process. So just to give you a quick introduction to both of those, and then also an introduction to a diagram that's going to help you determine whether the reaction is actually endo or exothermic. So in an exothermic process, the system transfers heat to the surroundings. And so a lot of people will say that it feels hot, and that's because you are a part of the surroundings. You are not a part of the system, you are a part of the surroundings. And so because that heat is being transferred to the surroundings, you are receiving that heat. So to you, it feels hot. Potential energy of the system is converted into heat energy that is actually released. It's not that the system cools off, it's that the system has potential energy stored in the bonds of its compounds, and when those bonds are broken, it releases the heat. And then with an endothermic process, the system absorbs heat from the surroundings. And again, you are a part of the surroundings. So the system actually sucks heat from you, and so because of that, it feels cool. And the temperature of the system doesn't actually go up because that heat energy, it doesn't stay heat energy in the system. It's actually converted into potential energy in the bonds of the chemical products that are made. So a quick potential energy diagram to show you the difference of these two. If we consider the reactants to be over here and the products to be over here, reaction coordinate down here on the bottom, that just really refers to the progression of the reaction. So here we have the beginning of the reaction, and here we have the end. And so when a reaction progresses in the forward direction, what happens is you're going to absorb this amount of energy right here. This is called the activation energy. It's the energy to get the reaction going. And then once you reach this magical point right here where you have actually absorbed enough energy for the reaction to just continue on its own, then you progress down to the products. And if you see here, the difference between the energy of the reactants and the energy of the products, the energy actually decreased. So the energy of the system went down. And so that means we have a negative change in energy, which makes this an exothermic reaction. Now the opposite of that would be this guy, where the reactants are down here and the products are up here. You still have to have this activation energy that you accomplish, this magical amount of energy that means the reaction will continue on its own. But in this case, the reactant energy actually had to increase, and so the system had to absorb energy, so we had a positive change in energy, which makes this an endothermic reaction.